Well, one of the things we want to do with GIS oftentimes is look at distance, right? So we looked at some other things like those containments and intersections and things like the buffering, but distance is another function that is usually really important. So here's the first query we want to look at. I'm interested in knowing the minimum distance between a parcel and a flood zone. Now let's talk about this query, and I'm going to tell you to not run this query. Let's come back in. There we go. Now we'll talk it through, and like I said, I don't want you to run it because I just ran it for you, and it takes 287 seconds to run. So we're approaching 5 minutes. I don't want you to have to sit and wait for that. And this tells me for every single parcel how far it is from a flood zone. And you can see all the zeros here, meaning it's in the flood zone, but some of them are further away. All right, so some are close, but not quite in the flood zone. So what are we doing here? Well, I'm selecting the distance, st_distance, between the parcel geometry and the flood zone. By the way, notice how all these look alike: st_distance, st_intersect, st_contains, st_touches, and then they require two geometries. This is what I meant before about not needing a special wizard. If I know how to do st_distance, I can pretty much figure out how to do st_intersects, and so on. So I'm going to return that as an integer. Now let's worry about the min later. We talked about min earlier. From the parcels in the flood zone where the distance is less than 300 feet. In other words, I don't want to look forever. If it's outside of 300 feet, I don't care. But the ones that are within 300 feet, that I do kind of care about. Like this parcel here is within not feet, but meters rather, 13 meters. Okay. Now I wanted to get the minimum distance because now every parcel, if you look here, and let's bring the flood zones up above. Actually, we'll turn the query result off, and we'll zoom in a little. Come down in here, and let's turn the watersheds off. All right, so every parcel has a distance. This parcel has a distance to the flood zone, and this parcel also has a distance to that flood zone, and this parcel also has a distance to that flood zone. So I don't want to do all those calculations. So in this case, I want to take the minimum distance and then group it by the parcel key. So in other words, for a particular parcel, for instance, this one here, okay, maybe this one. There we go. I'm going to get distances to this flood zone, to this flood zone, to this flood polygon, to this flood polygon, to this flood polygon, and so many others that are within 300 feet. But what I want is the one that is closest, so probably this one that we see down here. So that's what the min is doing. That's getting the minimum, but I also want to do the group by so that for every single parcel key, I'm going to have the minimum distance. And you can see we can span this number out a little bit further. So that's just a straight up SQL query, except we're using st_distance as a function rather than some other kind of SQL function, right? But the idea is that it all works. And again, we have this where clause because I don't want to look at every single one. But even still, this took almost 5 minutes to complete. So if we look here, I've got this st_d within. That's another command. Let's look at that. So this is similar to distance. Now st_distance was taking a geometry and another geometry and comparing them. Std within takes a geometry, another geometry, and then the distance that we're interested in. So before we were getting a distance, and then I'm also having to compute the distance again where it's less than 300. Std within allows us to put that 300 in there. Now there's another thing that's very important to understand about Std within is this idea here. It will make use of any indexes that are available on the geometries. You see, Std within makes use of the spatial indexing. We talked about indexing earlier in this class. St_distance does not do that. So this takes, again, 287 seconds to perform, and I don't want you to calculate that. But I am going to put this in. I'm going to run it. I'm going to shut off the video, and I'll get back when it's done. We're going to see this is going to run quite a bit faster. Same idea, but I've just changed the d within for the where clause. So I want to select the ones that are within 300 meters. So before we were selecting the distance that was under 300. Now I'm saying D within. So that's going to get that selection much, much faster. Notice also that D within returns true if the geometries are within that distance. So this is returning a Boolean. Okay, and that's different than ST distance. We can click on here. We can see ST distance returns a floating point value. So I'm going to click execute. We'll run this now, and I'm going to turn off the video and I'll be back shortly. And we're back, and that was 25 seconds. So I got the same results, but it only took 25 seconds. So a half a minute. So this winds up being close to 10 times faster by using the Std within because it makes use of a spatial index. Well, distance is so important in GIS and with SQL. Let's talk about what I would call many ways to skin an SQL cat and looking at distance. What I'm interested in doing is finding the sum of all the assessment values for residential properties that are within 300 feet of the AE flood zone. Okay, so this is something you might actually do, right? The mayor, the council, or someone says, I need to know how much property value is within 300 feet of the AE flood zone just for residential properties. So you're going to see there's not necessarily a right and wrong answer. There's many ways to get it, but some are more efficient than others. So let's first take this query, and we'll step through what it is we're actually trying to do. So I'm getting the sum of the assessment, and let's go back to what we've been doing before with the : numeric, : money, from, and now I've got a query here where I'm selecting the assessment and the distance from TC parcels where the flood zone is AE and the property class is residential. So this is a particular query, right, that does a straight up calculate the distance between the parcels and the flood zones, the residential flood zone properties and the flood zone that's AE. So I've got the where clause here. That's going to return a whole list of values. So then from there, since I have assessment, I'm going to sum that assessment, and I'm doing it and I'm collecting distance as dist where the distance is less than 300. So I can run this and we'll see how long this takes. So that is 0.27 seconds. That's really fast. Let's look at this one. This one is a little more terse. And now I'm saying I want to sum the assessment where the parcel from the parcels in the flood zone where the flood zone is AE and the property class is residential and the distance is less than 300. So let's run that. And this is taking a bit longer. And that took quite a bit longer to complete. And we'll come back to our queries again. So this, again, is creating a subquery here that appears to be faster than just the straight up query. So a lot of times you're going to have to experiment to say which one is faster for me. Here's another one as well. We'll use D within. And we'll come in here. And now that where clause is not where it's less than 300. Okay. In this case, now what I want to do is use the D within, and we'll run this. So that winds up running in 4.2 seconds. So which one is better? Well, again, this one seems a little more terse than the other ones, but still not quite as fast. So a lot of things that you're going to have to consider. But as you explore doing SQL commands, that's part of the fun, is to try to figure out and tease out what are the best approaches for skinning this cat. Okay, next one we'll look at is Std Intersex. And we've already seen the intersect command, but we'll go over it one more time. And I just put a little other wrinkle in here because we've been looking at intersection. But what I did here was I got this thing called D. Right, TC parcel, maybe I'm getting tired of typing that and spelling it. So I can say, select the geometry, the dgeom, and the parcel key from TC parcel as D. What we're doing here is we're pretending that TC parcel is a table called D now. And now I can refer to the elements in TC parcel with the table name D rather than TC parcel. So I want to select it from TC parcel and the flood zones where they intersect and the flood zone is equal to AE. So we'll run that. That's completed. And we'll bring up our map. And let's come in here and we can update it. And there we go. And let's turn on our query result. Okay, so there we go. That is the answer to the parcels that are intersecting the AE flood zone. Next thing we'll look at is Std Intersection, and we did this earlier in the class as well, but let's talk it through a little more. Remember, before we did, just to kind of whet our appetite. So I'm going to say select the intersection, the Std Intersection as some area. Okay, actually just the Std Intersection here, and then the Std area. So what we saw before, what the Std Intersection does, it actually clips the vector geometries with another vector geometry. So now I'm going to clip the parcels with the flood zones. So that's a true intersection. A new geometry gets created. Then notice the next parenthesis. I want to get the area of each one of those. Then I want to get the sum of those, and I'm going to call that sum area from the parcels as D and the flood zones, where they intersect. See, I don't want to return a bunch of null values. Here's the thing about SQL and all computers that you probably already know, is that computers are going to do exactly what you tell them to do. So if I say to intersect the flood zones with the parcels, all these parcels here that intersect the flood zone, that's fine. But this parcel too, I'm also telling it intersect this parcel with the flood zone, and what's going to get returned is null. So I'm going to have just gobs and gobs of null values. But when I put this predicate where they actually intersect, then we can only compare the ones that are currently intersecting. Now, Std Intersection is computationally expensive. So if I can reduce the number of times I try to do that by only doing it where they intersect, that's going to make life a whole lot easier for us. And I'm going to take out this parenthesis. We don't actually need that. And we'll let this run for just a moment. And it's done. So this is the total area of the properties that intersect the flood zone, the AE flood zone. And instead of that, I can just say d.geom where Std intersects. And that's good enough for me. So let's execute this. That's done. Let's update it. And then let's come back into our map. And that gets us the ones that intersect. So look at this property parcel. This one comes all the way out here. This one comes down here. So it's not necessarily in the AE zone. So let's say Std Intersection, and then we'll say dgeom and floodzones.geom as geom. So now I'm going to actually create the intersection. So we'll run this. It's going to take a little bit longer because, again, it's more computationally expensive. And it didn't take too long, honestly. Let's run this or update it. That's completed. And now look at what it's done. That same parcel that was extended over has now been clipped strictly to the flood zone boundary. Well, let's end it with Std Union. And if we look at the help file here, what we can see is Std Union takes a geometry and some kind of or multiple geometries and will combine them together. This is an aggregation. Okay, it works a lot like sum. So I can aggregate data, and then I can also group the data together. So here's some examples that they show. But let's go through this quickly. I don't want to do anything that's too difficult. Or that's going to be too time consuming. So let's say Std Union geometry from parcels where, and let's come back into our query here, where the municipality is Lansing. Now the reason I'm doing this is I just don't want to take too much time. So we'll just do it for a small part. So this is, well, let's run it first off. Oh, I've got to make it TC parcel. So we'll run that. And make this geom. That's better. Okay, so let's let this run, and I'll turn this off for just a second. Oh, it actually finished. So let's update our data, and we'll come back into Postgres, or excuse me, into QGIS. So what we now have is one big polygon of the parcels in Lansing. So you can see it's one big patch because these are all parcels in Lansing, and what we did was we unioned them. It would be the same thing as saying the sum of the assessment, right? That's an aggregate clause. Now, with that, I can also create a breakdown of it based upon prop class. So group by prop class, and then I can say up here, prop class. That's pretty easy to do. Execute that, and that runs really quickly. Why? Because we're not doing any kind of spatial operation here. So let's say st underscore union and then geom. So now, instead of working with just attribute data that's numeric, now I'm going to perform a union of the geometries, and we're going to group it by the property class. So let's run this, and this will take a little bit longer. Actually, to be honest with you, it didn't take that long at all, 4 seconds. So let's update the map. And now you can see we have different polygons, so representing the different land use types. So I can come in here and I can create a categorized variable, and I can categorize it based on the property class. And these are all the different ones. Let's hit apply. And we'll let this run for a second. And now we have an actual land use map. So the blue is the agriculture, this reddish brick color is the commercial, and so on. So what you can see is the polygons are now created or unioned or merged based upon their property class. So just the same way that assessment, the assessment value were summed, I can do the same thing because it's an aggregate clause. And this is again what I meant by spatial is not special. It's just another data type. If I can create aggregates on the assessment, I should be able to create aggregates on the geometries. Well, I think that gives us enough of a taste of the kinds of spatial SQL commands we can perform. So what I want to do now is look at some classic geographic models that are used in SQL.